In this video, we're going to look at the dot product using the component method. So the component method of determining the dot product is as follows. If the vector A is equal to A1, A2, and the vector B is equal to B1, B2, then A dot B will simply equal A1 times B1 plus A2 times B2. Very simple. And in R3, if A is A1, A2, A1, A2, A3, and B is B1, B2, B3, then A dot B will simply be A1, B1 plus A2, B2 plus A3, B3. Okay? So we're going to prove that in a different video, but let's get on right now to putting that really cool property to good use. Suppose we want to determine the angle between the vectors A equals 1, -3, 4, and B equals -8, 5, 7. Well, what we can do is simply recall the formula. A dot B equals the magnitude of A times the magnitude of B times cos theta. Rearranging that equation, we'll get that cos theta, simply dividing both sides by magnitude of A, magnitude of B, we'll get cos theta is equal to A dot B over magnitude of A, magnitude of B. Now, what does A dot B equal again? Well, it's just 1 times -8 plus -3 times 5 plus 4 times 7. What is the magnitude of A? Well, it's just the square root of 1 squared plus -3 quantity squared plus 4 quantity squared. And what is the magnitude of B? Well, that's just the square root of 8 squared, -8 quantity squared plus 5 squared plus 7 squared. Okay? So what we end up with is this really neat formula that is going to be pretty easy to use. We'll get help from our calculators. -8 minus 15 plus 28 is 5. So the dot product of A and B is 5. The magnitude of A is root 26, and the magnitude of B is root 138. And letting our calculator do the work and determining the cos inverse of that number, we'll get that the angle in between A and B is roughly 85.2 degrees. Now, what if we want to know for what values of k the vectors -1, 3, 4, and 3k -2 are perpendicular? Well, we know that two vectors are perpendicular if the dot product is 0. So that means -1 times 3 plus 3 times k plus 4 times -2 will equal 0. And then we have a pretty simple formula to solve. And that's what we have written in front of us. -3 plus 3k minus 8 will be 0. 3k will be 11. K needs to equal 11 over 3. How about if we have the vectors -3 and m-3, 6? Well, again, we'll do the same thing. X times x will give us m squared. The first y coordinate times the second y coordinate will give us -3m, and then -3 times 6 will be -18. So what we'll get is that m squared minus 3m minus 18 needs to equal 0. And if we factor that quadratic, we'll get that m minus 6 times m plus 3 needs to equal 0, so m will either equal 6 or m will equal -3. Now, suppose that we are given the vectors 4m, -8, and -2, 16n. We want to determine values of m and n that make the vectors either collinear or perpendicular. Well, let's start with collinear. We know that p and q will be collinear if they're scalar multiples of each other. So we're going to imagine that 4m, -8 is a scalar multiple of -2, 16n, and we'll let the scalar multiple be k. So looking at the x components, we see that 4 needs to equal -2k, which would mean that k needs to equal -2. Well, from that point on, the question's actually pretty simple for us. Since we know k needs to equal -2, and we know m is going to be k times 16, we know m will need to be -2 times 16. And since, again, k is -2, looking at the z's, we'll say -8 will be -2 times n, and we'll be able to solve for n. And we'll get one answer for each of those. So again, doing what we just did on the last slide, we'll see m needs to be -32, and we'll see that n needs to equal 4. So if the vectors are collinear, then m will be -32 and n will be 4, and there's only one possible answer there. Those two numbers. M has to be that value, and n has to be that value. But for perpendicularity, it'll be a little bit different. If the vectors are perpendicular, then 4m -8 dotted with -216n will equal 0. Well, that would mean that 4 times -2, which is -8, plus m times 16, which is 16m, plus -8 times n, which is -8n, all of that will need to equal 0. So that would mean, isolating n, that we would get n needs to ultimately equal -1 plus 2m. Now, we have one equation here with two unknown variables, and when that happens, there's an infinite number of solutions, so we're going to use a table of values. Suppose we let m equal 0. If we let m equal 0, then n will be 2 times 0 minus 1, which is -1. Suppose we let m equal 1. Well, then n would be 2 times 1 minus 1, which will be 1. And finally, suppose m is 2. Then n would be 2 times 2 minus 1, which would be 3. So if the two vectors are perpendicular, then we could have m equals 0 and n equals -1. Or we could have m equals 1 and n equals 1. Or we could have m equals 2 and n equals 3. Or there are infinitely many other possibilities as well. Now we want to determine here the acute and obtuse angles between the diagonals of a box measuring 12 centimeters by 4 centimeters by 6 centimeters. One way to do this is to put the box at the origin of our x, y, and z axes, and make one length here be 4. Since one edge of the box is 4, we'll call point B 4, 0, 0. And since another one is 12, we'll call that 0, 12, 0. And since another one is 6, we'll call that 0, 0, 6. Then what we're going to do, using the same ideas we used earlier with parallelepipeds, we're going to see that we can actually determine the coordinates of the other points on the edges. So for instance, if we wanted to know the coordinates of point E right here, well, we know that going from 0, 0, 0 to 4, 0, 0 involves adding 4 to the x. So again, involving moving that same vector, that same journey from 0, 12, 0 will involve adding 4 to the x, and we'll have 4, 12, 0 if we start at 0, 12, 0. And if we want to know the coordinates of this point up here, well, we just say that that journey from A to D will be equal to the journey from O to C. Well, we know that the journey from O to C involved adding 0 to the x, 0 to the y, and 6 to the z. So we do the same thing. Starting at 0, 12, 0, add 0 to the x, 0 to the y, and add 6 to the z, and we get to 0, 12, 6. Again, following the same idea of adding 0 to the y, 0 to the x, and 6 to the z, we can move from B to F. Since B is 4, 0, 0, F will be 4, 0, 6. And again, we can do the same thing here. So moving from adding 0 to the x, 0 to the y, and 6 to the z would get us up to the point 4, 12, 6. So however you think about it, you'll be able to figure out the coordinates of those other points. And now we can just draw in a couple of diagonals and figure out the angle in between them. So going from B to D, the vector BD, we would say 0 minus 4 is negative 4, 12 minus 0 is 12, and 6 minus 0 is 6. And similarly, going from O to G would be going from 0, 0, 0 to 4, 12, 6, and that would be the vector 4, 12, 6. And determining the angle in between those vectors would be using the dot product method. Since BD dotted with OG would be the magnitude of BD times the magnitude of OG times cos theta, we can isolate cos theta really easily and say it's simply BD dotted with OG over the magnitude of BD times the magnitude of OG. Ultimately, we would get that theta is equal to 33.2 degrees. And keep in mind, though, that we used vector concepts to answer this question, but we could have just as easily drawn the vectors the other way. So instead of drawing a vector from B to D, we could have drawn a vector from D to B. Had we done that, we would have actually, instead of gotten the angle 33.2 degrees, we would have gotten the angle 146.8 degrees. We would have gotten an obtuse angle because keep in mind those diagonals are meeting at the angle here, which we determined to be 33.2, but we could also say they're meeting at the angle here, which would be 180 minus 33.2. So the acute angle between the diagonals is approximately 33.2 degrees, and the obtuse angle between the diagonals is approximately 146.8 degrees. Now, something I want to mention is that if you drew different diagonals, so let's say you drew the diagonal from B to D that I have shown in yellow, but if you drew this other diagonal from C to E, instead of the one from O to G, if you drew this other one, you might have come up with a different answer. So there are different possibilities here, depending on which two diagonals you choose to draw. Now, for this question, we're going to imagine that the vectors A and B are such that A is negative 1, 4, negative 8, and B is 4, negative 3, m, and that theta, the angle in between them, is equal to cos inverse negative 16 over 45. Well, we're going to solve for m. We're going to see if we can figure out that value right there. Okay, well, we know that A dot B is going to be negative 8m minus 16. Negative 1 times 4 plus 4 times negative 3 plus negative 8 times m. Simplifying, we get negative 8m minus 16. Now, we know that A dot B will be magnitude of A, magnitude of B, cos theta. Okay? Well, the magnitude of A will be the square root of negative 1 quantity squared plus 4 squared plus negative 8 quantity squared. This is the same as the square root of 1 plus 16 plus 64, which is root 81, which ultimately is 9. For this vector here, we've got the square root of 4 squared plus negative 3 quantity squared plus m squared. 4 squared is 16, negative 3 quantity squared is 9. Adding those together, we get 25. So this is here the square root of m squared plus 25, and we still have cos theta. So putting everything together, we have negative 8m minus 16 equaling 9 times the square root of m squared plus 25 times cos theta. Okay? Now, we know that theta is equal to cos inverse of negative 16 over 45. So determining the cos of theta is like saying, what's the cos of cos inverse of negative 16 over 45? The answer, without needing to use a calculator, is negative 16 over 45. If it helps you to think of that, just think that the cos inverse of negative 16 over 45 is an angle for which the cos of it is negative 16 over 45. So whatever angle that works out to be when we get the cos of it, that simply will be negative 16 over 45. So we can actually sub that in right straight there. And when we do that, we get negative 8m minus 16 equals 9 times the square root of m squared plus 25 times negative 16 over 45. This 9 and this 45 can cross out the way I've shown there. Now we can factor negative 8 out from both sides. If we factor it out of the left, we get negative 8 times the quantity m plus 2. If we factor it out of the right, we get negative 8 times 2 over 5 times the square root of m squared plus 25. So we can divide both sides by that negative 8, and we get this, this answer right here. And now, at this point, I just want to mention something that'll come up later on in this question. At this moment, if we don't think to do this now, we might end up thinking to do it later, but it's good if we can think to do it now. We recognize that m squared plus 25 has a minimum possible value of 25. M squared has to at least be equal to 0. It can't be negative. So m squared plus 25 has to at least be equal to 25. So the square root of that has to at least be equal to 5. So this value right here, so long as m is a real number, the square root of m squared plus 25 must at least be 5. So the right-hand side must be at least equal to 2/5 times 5. Now, 2/5 times 5 is actually equal to 2. So the right side of that equation must at least be equal to 2. So that means m plus 2 must be greater than or equal to 2. Subtracting 2 from both sides, we get m must be greater than or equal to 0. If we can think to do that at this point in the solution, it shows good understanding of what's going on. And we know that by the time the final answer arrives, if we get a negative value for m, it will not be possible in these circumstances, because it would be impossible for such a number to equal 2/5 times the square root of this number. Something to consider for later. So at the end, if we end up with two answers, which we will, we want to make sure we don't keep one that's less than 0. Anyways, moving on with this, what we're going to do next, we're going to multiply both sides by 5, which we do. And then we're going to square both sides. So we're going to say 5 times 5 is 25. M plus 2 quantity squared is shown here. 2 times 2 is 4. The square root of m squared plus 25 times the square root of m squared plus 25 is m squared plus 25. Expanding out m plus 2 quantity squared gives us the polynomial m squared plus 4m plus 4. Distributing in the 25 gives us 25m squared plus 100m plus 100, equaling 4m squared plus 100. We can subtract 100 from both sides, and we get 21m squared plus 100m equals 0. We can then factor out the m, and we can say m is equal to 0, or ultimately m is equal to negative 100 over 21. Well, if you recall a little while ago, we said m has to be greater than or equal to 0. Right away, we know that that answer can't be correct. So we know the only possible answer is that m is equal to 0. But now suppose you didn't really do the restrictions the way we said a moment ago. What you would at the very least then have to do is check that one of those answers is not extraneous. And the way you would do that is by going back to the original and checking m equals 0 and m equals negative 100 over 21. If you let m equal 0, then you'll end up with putting that into the dot product formula. You'll end up with negative 16 equaling 9 times 5 times negative 16 over 45. And that's actually true, and we would be happy with that, m equals 0. But if we tried m equals negative 100 over 21, then when you plug those into the formula a dot b equals magnitude of a, magnitude of b, times the cos of theta, you would ultimately end up, after doing a bunch of work, you see it here, you can follow the steps if you want, you would ultimately end up with the statement 464 over 21 equals negative 464 over 21. Well, clearly that's false. And since that's false, that would mean m cannot actually equal negative 100 over 21. So you can see there's a lot of work involved in showing that that's extraneous. It's a little bit easier and shows a little bit more understanding if you can think of that as you're going through the solution instead.